hear you not talk, exactly. All right, so today we are doing a couple problems off worksheet 4B. The rest of 4B is in a homework assignment. And then we are going to do 5A and talk about basic polynomial long division and synthetic division. Not the actual purpose for it, kind of hard, more complicated problems today. We're just going to go over the review of the concepts. And then tomorrow we're going to finish section 2.3 and hopefully have a little bit of work time, and then Friday will be mostly work time, okay? All right. So, warm up. Can anybody tell me the degree of this problem? There's an x squared, an x, and this would become an x squared. After we FOILed it out, if we were going to, right? Not just because you can distribute a squared, that's not the case. But we would have a degree 5, because we had an x, what was x squared to x, and then an x squared. Leading coefficient, the only thing multiplied by any of those x's anywhere is this -4 out front. Okay, can anybody tell me anything about that shape? Yes, a basic cubic looks like this, right guys? But this one is got a negative leading coefficient. Now it's not a cubic, it's a degree 5, but the shape is the same as any, whoops, yep. Let me try that again. Okay, I was wrong in the beginning. Great video, Hofbauer. Okay, this is the basic cubic shape. So, because if you cube a positive number, you get a positive number. You cube a negative number, you get a negative number. So it should be in those quadrants, right? But if you multiply by a negative, it's going to be in the other two quadrants, so it's going to go this way. I was no help. All right, back up. End behavior should look like this. So can somebody tell me how we write that? You want to say up or down first? If we say up, then we're talking about the left side, which would be negative infinity. Everybody good? And it is down, which would be negative infinity. On the right, so x would be positive infinity. Okay, what are the zeros? Very important concept. Is -4 a zero? No. Okay, it reflected and stretched the graph. But the three numbers that would make this be 0 are, if we put in a 0 for this x squared, right? If we put in what in this term? -2, and back here if we put in a +3. Everybody good? Okay, 0, it has a multiplicity of 2 because that little exponent up there, that's all multiplicity means. -2, there's no exponent, it would be multiplicity 1, and you really don't even need to write that. And back here, this one has a multiplicity 2. Now, what does multiplicity tell us? First of all, if you add up all those multiplicities, it tells you the degree, but it tells you what, Luca? Perfect. He said if it's an odd multiplicity, the graph will pass through that 0 or cross the x-axis at that point. If it is an even multiplicity, it will do a bounce off or kiss the x-axis only, will not cross. I'm going to go with the word bounce if that's okay. So you should now have a perfectly general idea of what this graph looks like. Okay, it's coming down from the top left, yes. What is the furthest left 0 we discussed? -2, right? Comes down, and what does it do at -2? Crosses. Then the next 0 over to the right would be 0. And what's it supposed to do there? Bounce. And then at 3, it has another 0. And it's supposed to bounce there. Does that give it the proper end behavior? On the far right, it should be going down. Yes? Okay. Questions? Good job. Okay, now we got to work the other direction. We're going to be given the zeros, and we have to find the factors. Anytime you have a zero and you want to move to the factor, if the zero is C, the factor will be X minus C. Does that make sense? So if this happened to be a -2, the factor would be X plus 2. Everybody okay? It's the opposite. Okay, good job. Now down here, this graph, normally they just put them right at the, like this, here. This is crossing at -2. We're supposed to assume -1, 1, and 3, okay? But this one, number 1, they want us to assume this one is at -3, but this one is not at an integer, so they told us. That is -4/3. And over here, it's not an integer, so they told us that one is at 1/3. Now, there's 2 ways we can do this. I'm just going to use the straight up easiest way, and I can talk about if you want to be a little more mathematically complicated with it, okay? The easiest way to write that -2 is a 0 would be to put a factor of X plus 2. -2 is a 0, so X plus 2 is a factor. Now, -4/3 is a 0, so I'm going to put X plus 4/3 is a 0. We can talk in a minute about how you could have written that as what? Anybody know? 3x plus 4? 4x plus 3. Which is it? That's where people get confused. Yeah. 3x plus 4 would solve and say x is -4/3, right? But I'm not even going to go there because I don't want somebody messing that up. Let's go over here. The opposite of positive 1/3 would be an x minus 1/3. The second thing you have to worry about is multiplicity. Are any of those repeated zeros? Are any of those bouncing? No. Is it the right shape for the degree we currently have? We have a degree 3, and it's the right shape. We might need a negative coefficient, okay? But that'll take care of itself. Now, I do want to tell you, we've been using A for the stretch, and you're more than welcome to use A. I believe the quiz says K for the stretch. All right, so what are we going to do now? Well, we have to find a point that has been stretched. None of the x-intercepts have been stretched. They will give you one additional point, and that's what I do on the quiz. I give you one additional point, and that's what you have to plug in. What is the additional point they have shared with us here? It says the y-intercept is 0, 16, okay? It's the only point we know for sure other than the zeros. So we're going to put 0 in for x and 16 in for y, and we're going to solve for k. Everybody get that this is the same thing we've been doing all year for these kind of problems? It's just they're more complicated now. We're going to put the 16 in for the y. We're trying to find k when x is 0, because the ordered pair we had to put in was 0, 16. Now, this is kind of messy, but we can do all of this on our calculator. Over here on the right, this becomes 2 times 4/3 times -1/3. 2 times 4/3 times -1/3. So we have on the left, 16 equals k times 2 times 4/3 times -1/3. Now, I'm getting -8/9. Did everybody get that who did it on their calculator? If you did a math enter. Okay. We need to divide that over to the other side. So you could type 16 divided by, in parentheses, -8/9, and it will work to find k. In my little pea brain, because I don't have my calculator handy, I'm going to do the reciprocal. Everybody good that that's the same thing? Multiplying by the reciprocal, right? So negative 8 into 16 would go negative 2 times, so times 9. I'm getting negative 18. Did anybody get negative 18 on their calculator? So we get K equals negative 18. All right. So the final answer we came up with was Y equals negative 18, X plus 2, X plus 4/3, and X minus 1/3. We could type that into our calculator, and maybe we will on the next one. I'm just not going to take time to do this. You could type this in your calculator and set your window to what theirs is, guys. What's their window set to? Their X is negative 4 to positive 2, and their Y's are like negative 60 to 60. If you set your window to theirs and you type that equation in, it should show up as the same picture, and you could type some of those ordered pairs in. You could type negative 2 and it should be at 0. You could type 0 and it should be at 16. We can talk about that on the next one. Does somebody want me to take a second to go through, if you had written those differently, what it would have looked like, the factors? I can do it on one of them if you want me to, but I'm going to talk about number 4 as the other one we're going to do together. And then your assignment is going to be to finish this worksheet and then some problems on 3 tonight. You were supposed to have already finished 2.2. So, okay. What can you tell me? Somebody tell me something I need to know about this besides Luca. Ethan, tell me something, anything. It has a 0 at? So what would there be a factor of? Nicely done. Faith, can you tell me something? Anything? Where's another 0 at? Okay, 0, 0. Esmeralda, where should I put, because there's a 0 at 0, 0? Okay, I could go, it's usually minus, but plus would work because it's 0. What else could I do, guys? Could I just put an X out front? Is it the same thing? Okay, but that's fine. Let's leave it like this. I don't care. Tell me something else. Tim? Okay, 5/2 are 2.5. I wouldn't care if you use the decimal. I'm going to use the fraction because that's what's there, but it says X plus or minus, Tim? It's always the opposite, okay? 5/2. All right, the next thing I need to worry about before I go any further is multiplicities. Lucas? Oh, this is a bounce, and this is a bounce. So he said they should both have. Now, in theory, guys, it should have an even multiplicity. I could put a 4 there if I really wanted to go crazy, okay, and find another way that this could work. Just use 2s, okay? Just like the odd ones where they cross, just use 1. Don't get crazy because you're going to end up with a hot mess for your leading coefficient otherwise. It's bouncing here. He said I need a multiplicity, and here. And it's going to ask you on the quiz, explain the multiplicities and why. And you're going to say, I need a multiplicity on these 2 because that bounces, okay? It's not complicated. All right. Does it have the right degree right now? I have an x squared, an x, and an x squared. That would be an x to the 5th. Would that mean ends are going opposite directions? Yes, right? So odd degree, not multiplicity, odd degree, so the ends would go opposite directions. Okay, we're looking pretty good, so I'm going to put the y and the k. What point do they give us to enter in? Can I put 0, 0 in, guys? There's no stretch at 0, 0, so it's not going to help us find k. It is, in fact, one of the zeros. You can never put a 0 in to find a stretch. What's the only other point they gave us? Yeah, this lovely positive 1, negative 28.8. So we have negative 28.8. equals k times 1 plus 3 quantity squared times 1 minus 0 and 1 minus 5 halves quantity squared. You can literally type all that in on your calculator if you want. I'm going to do a little bit of it by hand here. Let's see, that would be 4 squared would be 16. This would be negative 3 halves. Squared would become positive 9 fourths. I'm getting 36. 16 divided by 4 is 4, times that 9 up there would be 36. Did someone do it on the calculator and get 36? Anybody not getting 36? Need me to check what you're doing? Okay, last step. We need to divide, yes. So we need to divide both sides by 36. Is it negative 0.8 or 4/5? Do I remember right? Did anybody divide it? It's negative 0.8, or you could call it negative 4/5. So our answer is negative 4/5. Can I move that x minus 0 out to the front as just an x, guys? So would that be okay with everybody? And an x plus 3 squared and an x minus 5 halves squared. Let's type that in. We are going to, two things. We're going to have to set the window right, but first thing, if you go to y equals and you have a plot on up here, your calculator's not going to do this right, okay? Does everybody know what I'm talking about? If you have a little black box around plot, go up, hit up, arrow, enter, back down till it's off. All right. Now, what was it again? Negative 0.8. I'm just going to use the decimal because it's easier for me to type. X and an X. Thank you. X minus 5 halves, or you could put 2.5, it would work. And I don't need extra parentheses around that, but I do need a squared. Okay, the window on the picture, guys, was like negative 5 to 5 and negative 60 to 60. Does that seem okay? Or negative 40 to 60, something weird like that. Just a rough estimate even of your window being the same as theirs. Otherwise, it's not going to look right. Wow, we're looking pretty good, yes? If I type trace negative 3, it's a 0. If I type positive 2.5, it's a 0. What was the weird point? 1? Look, 1, negative 28.8, perfectly. Okay, who's stuck because theirs isn't working? Anybody? Yes? Mode? You still have your plot turned on. Go to y equals. And you should not have these darkened at the top. Laura, can you check, see if she can help her? Is one of them up arrow, enter, till it's not got a black box there anymore? Now try it. Did it work? Okay. Yeah. All right. Did you want me to run through this one real fast with the other possibility? I can do that. Can anybody tell me what they would have liked to do? This would still be x plus 3, right? And this would just be crossing at 0. But did anybody want to write this as what? 2x minus 5? Would that work? That would be 5 halves, right, guys? And that would be squared. What's going to change? The K value is going to change because because you have now a 2 inside of that one. If we put in 1 and negative 288, 28.8, is that what it was, guys? 1 plus 3 would be 4. And 2 times 1 minus 5 would be negative 3, but when you square it, did I do something wrong? Oh, okay. This is 16 and 9. For a minute, I thought I was getting the same answer. It shouldn't be the same answer. 16 times 9 is 144. If you divide this by 144, I think you get negative 1/5 or negative 0.2. And that would be your K value here if you had put the 2 into this parenthesis back here. All right, and it'd be the same graph, I promise. Any questions? So I changed it by writing this factor differently, which changed the K value. I wouldn't mess with it and do it that way unless you're very confident you can get it right. Okay, so you need to finish worksheet 2, 3, or numbers 2, 3, and 5. What's the only one of those that has a bounce? Does 2 have a bounce? 5 is the only one that has a bounce, right? So you might want to write yourself a note here. Remember this bounce when you go to do that. Means you're going to have a multiplicity. All right, everybody good? Moving on to division. Worksheet 5A. I need you to put down your pencil for a minute and pay attention up here to a long division question. Yay! You need to remember the process of long division. Okay, remember you looked at this and decided how many times it went into this number. All right, 22 into 38 would go what? And the next step was to multiply first, right? 22 times 1. Then subtract. Then bring down. So we divided in our head kind of to estimate. Then we multiplied. Then we subtracted. And then we brought something down. Now we're going to go back 22 into 162. Well, 2 times 8 is 16, but I don't think that's going to work, so 7. 7 times 22, anybody? 154. And subtract is 8. Bring down this guy. 4 times that would be 88. It's not going to go 4 times, so we'd have 3, which is 66. And I think that subtracts to 18. Anybody checking me? All right, we need to talk about how you write that. Did I subtract right? Okay. In beginning of long division, you wrote this, yes? Remainder 18. Does anybody remember another way you can write that? As a fraction. How can you write it as a fraction? 18 over 22. So it is 173 and 18 over 22, which reduces, I know, but I don't care about that today. You are actually adding that on, which is important when it's going to be a polynomial that you need to put a plus in there. Okay, how do you check that problem? Does anybody remember how you check that? 22 gets multiplied by 173. Somebody tell me what that is. 3806, okay? And then what did you have to do to finish checking it? You added the remainder back on, right? And you got 3824, which was the dividend. By the way, the vocabulary is quotient, well, quotient and remainder. This is the divisor. And this guy under here is the dividend. Okay, can almost read that. Now do you feel like you kind of remember this process? Okay. You get to just watch again. We're going to talk both today about synthetic and long division. The process of dividing by long division is similar to what we just did. We're going to divide, multiply, subtract, okay, bring down. To set up a polynomial for a long division problem, though, you have to have standard form. What does that mean? Is this in standard form? I have to put the negative 12x squared, then my exponents have to go down, right? The other thing that has to happen is if this had an x to the fourth out here, you have to have a placeholder for any missing term, like this would have a 0x cubed when you go to divide it out. Do you remember that part? Placeholders? Okay. Synthetic division is fantastic, but it only works if what you're dividing by is x plus 5 or x minus 3. Okay? All right, here's the example that's done on your page. I think it's already done there, isn't it? Okay, so we're supposed to divide this right here by x plus 1. So the x plus 1 went outside, this mess went on the inside. It was in standard form, except it needed a placeholder for x squareds. Everybody good? All right. This is where students get really confused. You want this to multiply by something to become exactly this. You're dividing, but think about it as multiplication. X times what would become exactly 3x cubed? 3x squared. Now, it's not the opposite. You just keep it 3x squared. Then you multiply it by both of those quantities out there. And I don't know why people mess that stuff up, but sometimes they do. This is where everybody makes a mistake, though. The next step is where you subtract this quantity. I would highly suggest you use another color when you're taking the quiz, and you change this to add the opposite. So now I'm adding the opposite of those. So this becomes 0. Back here, 0 plus a negative 3x squared is a negative 3x squared. Use your calculator if you're not good with integers, because one little sign mistake at this point in the game messes up everything. You bring down the next term, which was a negative 2x. Then you repeat the process. X times what will become exactly negative 3x squared? Negative 3x. You multiply it by both of those terms, so you get a negative 3x squared and a minus 3x. Then you are subtracting this entire quantity or adding the opposite. Now adding the opposite gives me another 0 here, but back here I get a positive 1x. I bring down this minus 4. Can I multiply something by x plus 1 to get a 1x? Does x divide into 1x? One time, right? You still need the plus 1 back here. And then you multiply it by those, which is an x plus 1. And then you subtract or add the opposite. And you get back here a negative 5. And how do I write that? Plus the negative 5 goes over this divisor here of x plus 1. So this is the polynomial written with a remainder of a fraction. If I wanted to check it, I would do 3x squared minus 3x plus 1. I would FOIL that times the x plus 1, and then I would have a minus 5 on the back. And I'd have to FOIL it all together and then subtract 5 and combine like terms, and it should get down to 3x cubed minus 2x minus 4. All right. I am going to skip down to problem number 1 on your worksheet. I don't know where this is, but go with me, please, to problem number 1. First of all, how do I write it? 2x minus 1 out here, and 2x cubed plus 3x squared minus 8x plus 3 out inside of there. Did I need any placeholders? No, because I had a degree 3 term, a degree 2, a degree 1, and a constant. We're good. Okay, 2x needs to become exactly 2x cubed. What would it need to multiply by? Okay, I heard 2 different answers. Just an x squared, yes? Because it already had the 2. So now 2x times x squared is 2x cubed. So we did that part right. But we also have to multiply the x squared by minus 1, which makes it a negative 1x squared. Now here's where if you have a different color pen, you are subtracting this quantity or adding the opposite. And that is where everybody makes a mistake on a sign. And once you've made a mistake, the whole rest of the problem is wrong. This should be 0 if we did it right. But back here, what happens? Positive 4x squared. I can bring down the minus 8x. Now what? 2x has to become, multiply by something to become exactly 4x squared. A 2, positive 2. So you need a plus in there because this is a polynomial, not just a straight up number. Here we need a plus 2 and an x, you're telling me? So 2x times 2x is 4x squared. The 2x times the negative 1 back here is a minus 2x. I am subtracting that quantity, which is the same as adding the opposite. So I get back here what? Negative 6x. And if you're not good with integers, use your calculator. Plus 3. Okay, what do I need to multiply 2x by to become negative 6x? Negative 3. So negative 3 times 2x would be negative 6x. Negative 3 times negative 1 would be plus 3. If I subtract, or change the signs and add, comes out 0, yes? Questions? All right, I would like you right now to attempt number 2, please. Yep, big problem. Do we need any placeholders? Where? We have a 2x cubed, a 5x squared, a negative 7x, and a 6. None of those needed a placeholder. And out here we have an x squared plus 3x minus 4. X squared to become a positive 2x cubed needed to multiply by a what? Just a 2 and an x. Did everybody get the first one right? So that 2x times x squared would be 2x cubed. But then what do I get? I got to distribute this to all of that. 6x squared minus 8x. Did anybody get the subtraction right? This is usually where it goes badly. Kaden, what'd you have after that step? Okay, let's check him out. He went add the opposite. That's 0. Good job. Opposite of this would make it a negative 1x squared. Good job. Opposite of this would make it positive 8, and negative 7 would be positive 1. And he brought down the 6. I think he's golden. Yes? Now, x squared needs to become exactly negative x squared, so I need to multiply it by negative 1. All of that up there by a negative 1 would become negative x squared minus 3x and a plus 4. If I add the opposite of all those, so change all my signs because then I can just add. This is 0, this is 4x, and this is 2. Now, what would I multiply x squared by to become 4x? I'd have to multiply it by 4 divided by x. Yeah, I don't want to have a 4 over x up here, right? I'm good? The higher exponent power is here. I can't make it into this unless I divide out an x. So my answer is 2x minus 1 plus the quantity 4x plus 2 over x squared plus 3x minus 4. If I wanted to check it, I'd have to take x squared plus 3x minus 4 and distribute a 2x minus 1 through it. Do you want me to actually do this? And then on the end, I'd have to add a 4x plus 2, the remainder. So I have a 2x cubed. The x squareds combine to give me 5x squareds. Negative 7 and negative 3 is negative 11, plus 4 is negative 7. And I have back here a 4 and a 2, which is a 6. So it did FOIL back to that, right? And I added the remainder in. Lovely. Okay. Questions? All right, I have more practice on that if we need it. But let's go back and talk about synthetic division. If we go back to B, the top, this could have been divided. Was it the same question? We did long division? Yes. We're going to do it with synthetic division now. This is where students go wrong, guys. X plus 1, you have to put the 0 in this box, not 1. The 0 for that is negative 1. Everybody good? And then you write the coefficients across the top, which are 3, 0, negative 2, and negative 4. Why did I need a 0? 0x squared. I needed a placeholder there. Then after you write them across, it is drop the first one down, and then it's multiply, add, not subtract, multiply, add, etc. So I drop the 3 down. Negative 1 times 3 is negative 3. I add to 0 down, and I get negative 3. Then I multiply again. Negative 1 times negative 3 is positive 3. I add straight down and get 1. I multiply negative 1 times 3, or I'm sorry, negative 1 times 1 right here is negative 1. I add straight down and I get negative 5. This is your remainder Always, whatever that last item is it's a remainder. Then this is your constant term. This term gets an x for a linear term, and this term gets an x squared. So I have a 3x squared minus 3x and a plus 1 with a remainder of negative 5 over the divisor, which was x plus 1. Anybody lost? Is that what we wound up with when we did it the other way? No? Thank goodness, yes. All right. Down at the bottom, which one do you have? Do you have this number 3? Okay, do that one. What goes in the little box? Negative 4. And across the top, be careful. A 1x cubed, a 0x squared, negative 28 and negative 48. And the first step is drop the 1. Now multiply, add, multiply, add, multiply, add. Be careful. It's usually the adding 0 that does someone in. Anybody get that right? Say it again. Oh, we maybe later will have to do some factoring of this, but right now, how do I write that answer? Okay, so the answer we came up with was x squared minus 4x minus 12, because again, remainder was 0, constant term, linear term, squared term. Okay, if I wanted to check it, I'd multiply it by x plus 4, make sure it all foiled out and became that. So guys, on the next part of the lesson, let me preview tomorrow real fast. Tomorrow I'm going to ask you, was this a factor? If 2 is a factor of a number, it goes in evenly, yes? Did this go in evenly? Yes, it divided out with no, so x plus 4 is a factor. And then we're going to work on continuing to factor this, yes. Okay? So tonight's homework, guys, is these 4, that's it. 2 long division, 2 synthetic division, I think, okay? Plus finish worksheet 4B, where you had 3 questions on 4B.